All right, good day, everybody. My name is Jason Strait with the Cloud Pass Virtual Group. Our presentation today is going to be ETL 2.0 Data Engineering with Azure Databricks. Our presenter is Asanka Padmakumara. All right, kind of got that right. I practiced it a bunch of times. Sorry about that. He'll be taking over here in just a couple minutes. But before I do that, I got a few announcements that I want to go through. The presentation today is being brought to you by Quest. They are our sponsor. Quest provides Spotlight Cloud, which is the first Azure-hosted database performance monitoring solution focused on SQL Server. It does leverage Azure Cosmo and gives you the ability to get insights into your databases from all the years that they've been building management tools. So if you haven't seen one of them, their presentations previously with the virtual group, I recommend checking that out. It's a pretty cool tool, especially when you're monitoring SQL Server in the cloud.
Thanks. So first of all, I would like to thank you for Pass Cloud Virtual Group for providing this opportunity for me. So let's start today's session. So my name is Asanka Padmakumara. Today's session, I'm going to talking about ETL 2.0 Data Engineering using Azure Databricks. Before starting the session, let me introduce myself. As I said, I'm Asanka Padmakumara. I'm business intelligence consultant in a company called Fortude. I have worked related to BI and data warehousing close to 8 years now. I'm a regular speaker at data-related events such as local pass groups as well as the SQL Saturdays around the world. And you can go to my blog and you can connect me via my LinkedIn profile, and you can follow me in my Twitter. And I'm a Microsoft certified solution expert in data management and the analytics. The next question comes is where I am from. So this is where I am from. I have not mentioned my country, but if you are anyone interested in traveling, anyone interested in nature, you can see that I'm from a beautiful island close to sea. And if you can search, it's the best place to travel in 2019 in Lonely Planet travel ranking. And I'm inviting you, search the country by these clues and you can find out where this beautiful country is. And this is my first webinar, although I have done a set of local presentations and as well as international presentations. This is my first webinar, so your feedbacks are important. So if you have your mobile phone with you, please scan this QR code. It will direct you to a portal where you can submit your feedback on the webinar and its content. And I find this very important for me in my future works, future webinars, as well as future presentations. So please spend some seconds to scan this QR code, then give you a feedback at the end of these sessions. And I will again show this QR code at the end of the sessions if you didn't get enough time to do that. Right? So let's start the session without going to any other details. ETL 2.0. Now if you do search this term ETL 2.0, you will not find much in internet related to this word. The reason is ETL 2.0 is not a real term or a concept, but it's a new way of handling ETL. Now the question comes, okay, if you are talking about ETL 2.0, what's the issue with the ETL 1.0? Why do you need to talk about another version or another enhanced version of ETL tools? There's a reason for that. Whatever ETL tools available right now in the market, there are some limitations or the issues, and because of that, people started to talk about an enhanced version of ETL tools, right? So what are the problems we have right now? First one is difficult to handle large volume of data. The most of the ETL tool, even if you talk the SSIS, it could be the Pentaho, it could be the Talent, all these ETL tools, it's not easy to handle large volume of data. These tools work perfectly fine if you're talking about megabytes of data. But if you start talking about gigabytes of terabytes, this tool does not do their job. The next thing is unable to handle real-time data extraction. Again, these tools work perfectly fine when you extract historical data in a timely fashion. But if you want to extract the data in a real time, these tools does not satisfy your need. Other thing is difficult to handle unstructured data. Now all those tools are working perfectly fine when it comes to extract data in files or tables in a basically structured manner. But when it comes to handle unstructured data formats such as JSONs, these ETL tools doesn't do a good job. Other thing is platform dependent. Now if you go for the SSIS, if you consider SSIS, SSIS works perfectly fine in Windows platform on top of this SQL Server. So your SSIS or the extraction tool depend on your platform. Same goes to the platform implemented by maybe IBM, maybe Oracle. Those tools depend on their respective platform. And when you want to perform ETL operations, they require dedicated hardware. Again, same example, if you consider SSIS, it needs a dedicated server to run SQL Server and dedicated hardware for that matter. And the performance issue. Now these tools works perfectly fine when you extract the megabytes of data, but if you go for a large volume of data and if you do a lot of complex data transformations, performance is always an issue when it comes to these tools available in the market. Next thing is flexibility. Now the amount of thing you can do in this ETL tool always limited to the amount of features provided by these tool vendors. If you go for the most familiar ETL tool, same thing I took is SSIS. The features or the implementations is always limited to the amount of tasks or the control for tasks or the data for tasks is provided by the SSIS developers or the Microsoft. Now in that case, you don't have much flexibility to do a data manipulations. Right. So these are the limitations people face when it comes to current ETL tool. So people start talking about new way of handling ETL tool, which is called ETL 2.0. Now let's go to what kind of ETL tools available, ETL options available in Azure Cloud. The first one is Azure SSIS Integration Runtime. Now Azure SSIS Integration Runtime is you can push your ETL on-prem SSIS packages to cloud using Azure SSIS Integration Runtime. Next option is Azure Data Factory. Now Azure Data Factory is data orchestration platform, and inside that they have added new feature called data flow, where you can do the data manipulation, data processing, same as you do in the SSIS. Next option is HD Insight. You know, it's a clustered distributed processing cluster. And other option is Polybase. Now the Polybase is available in Azure. It's not available in the Azure SQL database, but if you go for a VM, that option is there, SQL Server VM. Or if you go for Azure SQL Data Warehouse, you can use Polybase to read data from multiple sources. Could be outside your Azure environment. It could be the data in your Azure environment. You can read that data and process using Azure SQL Data Warehouse. Another popular option is Azure Data Lake Analytics. Now, Azure Data Lake Analytics is a tool developed by Microsoft, and it provides you the facility to write the code, a language called USQL. It's a combination of SQL as well as a C#. But with the introduction of the Databricks, apparently Microsoft has trying to remove the Azure Data Lake Analytics from their cloud platform. Still it's available, but they do not promote it anymore. And the next option is the Databricks, which I'm going to cover. And there's another option. If you are a business analyst or if you are not in a data engineer, you can use Power BI data flow to do your normal day-to-day reporting requirement data extraction options. Okay. So these are the options available when it comes to Azure for your ETL jobs. However, when it comes to Microsoft recommends Databricks for 3 main operations. Although there are a set of ETL tools, Microsoft said that, okay, for these purposes, please use Databricks. What are these purposes? Advanced analytics on big data, real-time data analytics, and modern data warehouse. So let's go one by one. Now, if you are to perform advanced analytics on big data, data preparation as well as transformation, Microsoft recommend to use Azure Databricks. Now, this is the architecture Microsoft itself propose you to follow when you're performing advanced analytics on the big data. This architecture is taken from Microsoft website. They said that, okay, if you want to perform big data analytics, this is the tools and the architecture you should use. In that, you can see that I have circled that part. If you want to do when you do the preparation and the transformation, your choice should be Azure Databricks. Same goes when you do the real-time data analytics. Now, when it comes to real-time data analytics, again, preparation and transformation should happen either in the Polybase as well as maybe incorporate both Polybase as well as the Azure Databricks. And if you are implementing modern data warehouse, which the word data engineering comes to and which I'm going to cover into this presentation, you need to use Azure Databricks when you are implementing modern data warehouse. Your data can be in different formats, but always preparations and transformation recommended approach is to use the Azure Databricks. Remember, in the previous slide, I showed there are multiple options to do the ETL, but when you're implementing a modern data warehouse, Azure Databricks is the preferred choice. Now, let's talk about what is Azure Databricks. Now, Azure Databricks is nothing but Apache Spark based on analytical platform in Azure. So it's basically fully managed Spark cluster in Azure. It's designed by the founder of Spark, and basically what they did is Databricks is a separate company. They implemented the Databricks on top of the AWS first. Then Microsoft see that the capabilities of Azure Spark, and they talk with the Azure Databricks, and they wanted to have same platform in the Azure as well. So Databricks is a first partner, which means that they have access to all the information in the Azure. So they incorporate the Microsoft and created the Azure Databricks. Now, if you pay attention to this picture here or the charts here, it shows the how fast, basically the performance of Azure Databricks. Now, if you can see, this is basically this benchmark is done on top of the AWS, not in the Azure, but same thing applies to the Azure as well. Now, Spark is the fastest available distributed data processing engine right now. But if you consider Databricks, again, a fully managed clusters of the Spark is faster than the vanilla or pure Spark itself, which means that Databricks is the fastest available data processing engine, distributed data processing engine right now in the world when you compare to the any other data processing engines, right? So let's talk about main features or what Microsoft add to the Databricks. What Microsoft or the main features of Databricks that we can use when it comes to Databricks. First one is one-click deployment, which means that you do not basically Spark or when it comes to Spark is a distributed cluster. You need, in this case, you do not need to do any deployment. You do not need to maintain do the configuration or anything. You just a matter of you do few clicks and your cluster will be up and running in the cloud. Other one is auto scaling and auto termination. I will cover this in detail in the next few slides, so I'm not going to talk about that one. Optimized connector to Azure storage platform. Now, Databricks, as I said, work closely with the Microsoft Azure, so they have implemented connectors which are optimized to Azure storage platforms such as blob storage, data lake, likewise Azure SQL data warehouse. So when it comes to Azure Databricks, it works smoothly and faster with Azure storage platforms. And it works with Azure AD integration. So authentication and authorization happens in Azure AD integration using Azure Active Directory. So you do not want to implement security and you do not want to implement authorization from the scratch. You can use Azure AD and it supports enterprise grade security. So security I will cover in another slide. So I will not go to detail in this security as well. So let's go to the Azure Databricks ecosystem. Now if you consider in an organization, we have data science people, we have data engineers, we have business analysts, we have different peoples, different domains, different sectors who work in the data. And as well as our data can be in the lot of platforms, different platforms like blob storage, Azure Data Lake Store, Azure SQL Data Warehouse. If you are an open source fan, maybe Apache Kafka or Hadoop storage. Now what we want to do is, what these people want to do is, they want to extract those data and process this data and consume this in different application. It could be a visualization app like application like Power BI, or maybe they want to process the data and save the data in some data warehouse for a later another more advanced analysis or to analyze later, or maybe they want to analyze a streaming data source, or maybe they want to perform some machine learning algorithms once they done the processing. So in order to do that, again, this data must be processed first. So that is where Azure Databricks comes to play. So as I said, the core component of the Azure Databricks is Apache Spark. So apart from that, Databricks give you value addition on top of that. So it has Databricks enterprise level security, database IO, Databricks serverless, Databricks runtime, and workspaces and workflow. I will not cover each and every component of the Databricks because I don't have enough time to cover everything. But understand that Databricks is a platform implemented on top of Apache Spark, which facilitate you to process your data. Okay, let's have a look on, it will not be a deep dive onto the Apache Spark because it will take whole day to talk about Apache Spark, but I will speak about little bit about Apache Spark. Now Spark is distributed data processing engine. Again, remember, distributed data processing engine. And the key component is in-memory data processing. Now if you are familiar with another distributed data processing engine is MapReducer, Hadoop MapReducer, but the difference is this is faster than Hadoop MapReducer, and one of the main reason for that one is this is in-memory based. So Apache Spark support Java, Python, Scala, R and SQL. So it's another benefit. Based on your preferences, you can use either Java or Python or Scala or R or SQL to write your code and do the data processing. So Spark is used in data integration, maybe machine learning, stream processing, interactive analytics. You can use Spark in all those to cater all those kind of requirements. Now if you pay your attention to this visualization, this is how the Spark works. You have a cluster manager. So Spark comes with their own cluster manager, or Spark can be worked with Yarn, Apache Yarn or Mesos likewise. They support the different cluster managers, and it has as I said, the distributed processing. You have a driver as well as a worker or executor. So your code is written and passed into driver. So driver understand your code and distribute your program among the executor as well as distribute your data among the executor. So what it does is executor get the portion of your data and apply whatever the code, whatever the application processing you want it to happen, and submit the output to the driver. Driver collect the output data and pass the output to you. That's how the Spark distribution happens. Clear? Now let's go to the walkthrough to the Azure Databricks. Now if you are Azure Databricks, you need to go to the Azure portal. In the Azure portal, if you want to create a Databricks, just type Databricks and it will show services under Databricks, and I have created a one Databricks under my name, and if you want to create a new one, you just click add and provide the name for your Databricks workspace as well as a subscription name, and you can create in a new resource group or you can use existing report group, resource group, and you can select the location and you can select the pricing tier. It could be standard, premium, or you have a trial for 14 days into the premium. There's a new feature called you can deploy your Azure Databricks workspace on VNet. This is a preview feature which came, I think, few days ago. Now Azure Databricks supports VNet, so you can select your VNet based on your security requirement. So if you said I want to deploy in a specific VNet, I can select which VNet you want to deploy your Azure Databricks. Okay, so I will not gonna create the Databricks. I'm gonna go to my existing Azure Databricks. So I've clicked the existing Azure Databricks. It will come to it will open a panel like this, and there you have something called Launch Workspace. So if you click Launch Workspace, it will log into the Databricks portal. Now remember, Databricks is a fully cloud-based solution, which means that all the configurations, management, development, everything happens inside your web browser. So you have to write the code in web browser. So far, Azure Databricks does not have a development tool. It supports RStudio. Apart from that, it does not support Visual Studio or any other Eclipse or any other tools as far as I know. Right. So if you go, this is the landing page, Azure Databricks. So it has a common task in one section where you can create notebooks, you can upload data, create table, create clusters, create job, and there's now new thing called create machine learning experience, and you can import the libraries. And another section you have what are the recent files, and you have a documentation section. Now if you go to the document sections, it's provide comprehensive lot of documentation when it comes to import, when it comes to data engineering or the data processing. For example, if you click on the importing data, it will open a page which provide all the code you need to connect to different data sources. By default, it supports CSV, JSON, Avro, and Parquet files. But apart from that, there are other connections, configurations which are available. You can select whatever let's say if you want to connect to Azure Cosmos DB, and it will provide all the informations, and it will provide all the required code you want to connect to Azure Cosmos DB likewise. So these are the code available. Just a matter of you copy and paste this code and execute this code, then you are good to start your coding. Okay, go back to the portal. Left hand panel, so you have a home tab which shows all the available users inside your workspace, and it will show all the folders, workspaces available, right? So workspace is more like a logical container where you can incorporate your codes, or we call the notebooks or libraries and clusters, everything you can put into a logical container. And that is where it is shown, and you have a recent file or the recent notebook files which you have used so far. And that's another tab called data. So that is where you can create tables, databases. So you can see there are a few databases that I have created, and within the database you can see that there are multiple tables. Now these databases and tables are behind the scene. Apache Spark uses Hive to maintain relational databases and tables. So all of these are Hive databases and Hive tables. And this is the important part, clusters. Now as I said, Databricks is nothing but a platform implemented on top of Apache Spark. So here is where you create your cluster. Now if you want, I have already created one cluster called Data Engineering. Let me show you how to create a cluster in Databricks. Just click the create cluster. So here you can provide the name. Okay, let's say that was virtual group. And here next thing is cluster mode. Now let me explain what is the cluster mode means. You have two options in cluster mode. One is high concurrency, other one is standard. The high concurrency means, let's say in your organization you have set of data scientists, right? Not a one person, you have a team of data scientists, and all of those data scientists use this cluster for their experiment, their data processing and data manipulations. If the different people excuse me, the set of people are using same cluster, you need to pick up high concurrency as your cluster mode. On the other hand, if you are performing ETL operation in a scheduled manner, whereas in a timely fashion you want to run some data extraction and data processing jobs, you should select standard. Hope you guys got it. High concurrency means if multiple people are accessing the same cluster at the same time. And the standard means is basically to execute the jobs at a given time. So in this case, I'm going to select standard because I'm going to talk about data engineering. And the next one is Databricks runtime version. Now the Databricks is a platform created on top of Azure Apache Spark. Now, which means that they do the enhancement, they create multiple versions based on the requirement when it comes to Databricks. So as you can see that there are multiple versions of Databricks available when you want to creating a Databricks cluster. So starting from the 5.3 and go down to the 3.5 LTS. Now, I want to show something like this one, 5.3 GPU, which means that if you want to perform graphical processing, which means that if you want to do image processing, video processing, you should select GPU database runtime. At the same time, if you want to perform machine learning, you want to select 5.3 ML. So what happens is these database runtimes are optimized for specific tasks. If you consider 5.3 ML database runtime, it is optimized to perform machine learning, as well as it contains most of the machine learning algorithms inbuilt to the database runtimes, machine learning libraries inbuilt to the database runtime. That is what you consider based on your requirement. You need to pick right database runtime. So in this case, I will pick 5.3 because I'm going to do normal standard data engineering. Next option is to select the Python version. Now, based on your preferences, you can select either to use Python 3 or Python version 2 for this cluster. So if you are familiar with Python version 2.0, if you are not familiar with 3 or you are not sure about 3, and if you are mostly using the 2, you can pick the 2 if you want. By default, it will be Python version 3. I will talk about this section later, and I will straightly jump into the worker type and the driver type. So as I said, Azure Databricks is a cluster and cluster of nodes. So behind the scene, you will have set of Linux VMs as a worker node as well as a driver node. You will have one driver node and you can have a multiple worker nodes. So you can select what kind of worker nodes or what kind of VMs I want to in my cluster. So they have categorized into general purposes, general purpose hard disk drive or remote HDD, memory optimized, storage optimized, computer optimized, likewise VM, and the GPU accelerated. So which means that if you want to do a data engineering, you can select general purpose VMs, and each VM, it mentions how many cores are there in each VM and what's the available RAM or the memory in each VM. So based on your preference, based on your data requirement, your processing requirement, you can select what kind of VM you need. I want to specifically talk about memory optimized and the computer optimized. Let's say you have a large volume of data, set gigabytes or terabytes of data, but the transformation you perform on top of this data is not that complex. So the data volume is high, but the transformations or the data processing is not that complex. In that case, you should select memory optimized VMs, which means that which has higher memory, comparatively lower virtual cores, the vCores, right? But if you want to perform very complex algorithms, very time consuming or computer consuming, resource consuming processors, you should go to the computer optimized. In here, the memory is not big as much as memory optimized, but if you can see, you can go up to 74 cores in a VM. So based on understand your data, understand what kind of data operations you want to perform, then you select your worker node types. And by default, I said that you can have multiple worker nodes, but you can have only one driver node. So select the driver node. By default, it will be same as worker, but based on your preferences, based on your data volume, you can select different sizes for your driver. So remember, driver is the one will coordinate your data executions and will coordinate all the sessions and all the other related Spark related attributes are maintained by the driver, even when all the workspaces are kept in driver node. Now go back to this autopilot option. Now this is very important one, and this is very critical you understand these options. The first one is enable auto scaling. So by default this is enabled. If you remove this one, you can see that the min workers and max workers will go off. It will say only workers. So auto scaling means that, let's say you have 10 small files and one large file. So when it's come to processing the data, all right, when it's come to processing the data, 2 worker nodes will be more than enough to process those 10 small files. But you know for a fact that when it's come to processing that large file, 2 worker nodes will not be enough. It will need maybe 4 or 5 worker nodes, because the file is too big and you want to, it will take a lot of time to process. So what you can say that, okay, you can enable auto scaling and say that minimum number of workers is 2, maximum number of workers is 4, or whatever the size you want. So what will happen is database will understand that, okay, when it's processing those 10 small files, okay, it will understand that there's no performance issue, there's no bottleneck in memory of the CPU in these 2 worker nodes, so 2 worker nodes is fine. Immediately when these 2 worker nodes start to process that large file, it will see that, okay, CPU and the memory is not enough, so we need to add more nodes to my cluster. So this cluster, and what they do is it will add 2 more nodes depending on your max worker node, max worker configuration. If you say 6, it can add 4 more workers in order to process that large file. Soon after it is being processed, Azure Databricks sees that, okay, now there's no more big files. Again, it's a set of small files. Those 6 worker nodes are no longer required. Then those nodes will be detached from your cluster. So you will be costed, you will be built only for those nodes. So this is a very important one. So you don't have to scale out your cluster. Databricks will do it for you automatically based on the size of the file, based on the memory or the CPU workload. It will automatically add more nodes to your cluster. Next one is this one, auto termination. This is again by default is on, and by default it says that 120 minutes, which means that now you will be costed for number of hours or number of minutes your cluster is up and running. So let's say you process set of files and you forget to down your cluster, you forget to stop your cluster. Then what will happen is you will be costed for whole day or the whole period you will be using this cluster. Even though you are not using this cluster. So if you check this box, say that okay, soon after I finish my job, and if I'm not using this cluster for this number of minutes, then you can stop this cluster and it will not bill for you. So you can say that from minimum to 10 minutes and for the maximum of 1000 minutes, you can say that okay, if my cluster is no longer being used, please shut down this cluster, don't bill for me, and Azure Databricks will automatically do that for you. So these features is very important. This is something Microsoft Databricks offers from as a value addition to your database or on top of the Spark. And there's something called advanced option. Now if you are the expert in Spark, so Spark has a lot of configurations, right? So those configurations, if you manipulate it correctly, you can improve your performance. By default, Spark Databricks is fully optimized for the normal general working workloads. But let's say you have specific work requirements, specific Spark configuration, that option is again provided in advanced option. So if you know what you are doing, you can set Spark configurations manually in advanced section. Right. That is an overview of Databricks. So let's go back to the slide and we'll talk about today's specific task about data engineering. Now let's come to data engineering. Spark ecosystem has different components. If you start from the bottom, you have a low-level API where you can do the RDD or resilient distributed dataset manipulation. You have a distributed variable that is low-level API, and they have provided structured API which manipulate dataset, DataFrames SQL. That is what I'm going to cover, and on top of that, we have structured streaming, advanced analytics, libraries, and ecosystem. These are the components of Spark. In today's session, I'm going to briefly cover the structured API because that is what comes to play when it comes to data engineering. Let's start with DataFrame. Now the DataFrame API is basically untyped API, which means that you have rows and columns inside the data frame. If you're coming from the database background, it's the same concept as a SQL table or a Excel spreadsheet in that matter. Now you can think that okay, spreadsheet or Excel SQL table is in a single machine. But when it comes to data frame, you can think as your spreadsheet is divided among multiple nodes. That concept is called partition. So your data is partitioned among multiple nodes. One thing to remember, the data frame object is immutable, which means that you cannot update the data frame. So if you cannot update the data frame, you might think, okay, if I cannot update the data frame, how do I process it? How do I do transformation? How do I update it? How do I join it? Likewise. That I will cover how to do that. Let's go to the Dataset API. Dataset API is different from the data frame. What's the difference is, it's a strong type collection. Now if you can remember, data frame is untyped, which means that whatever data available in there is more like it's rows and columns. It does not understand any types inside the data. But dataset is not. It's a strong type collection. You will understand it when I'm explaining this sample in the right hand side. Remember, Dataset API is not available in the Python and R. There's a reason for that. Python and R are dynamic type, which means that it does not have types for the object. So when there's no type, you cannot create a strong type collection. It's slightly slower than the data frame. The reason is it has a compilations. It have a data synchronize. You have to put data into a class, so it is slightly slow, but it's not. It happens when it comes to very large volume of data. but not in the small amount of data. And it allows Lambda functions. So if you are coming from the programming background, you know that Lambda function is a very great, very powerful way of manipulating data, applying the functions on top of the data. So it allows you to write Lambda functions if you are using Dataset API. So when to use Dataset? First thing is, if you need type safety on your data, use the Dataset API. And if the data frame does not support required operations such as Lambda functions, you can use Dataset API. To get a better understanding about dataset, let's look at this sample. Now here we have a Parquet file which have a flight data. Inside the Parquet file, you know that the data is one field which has a destination country, one field is origin country, other field is count. So how many flights between destination country and the origin country. So you know that these are the information available. So if you want to put this information, destination, origin and count, into a class or object, you can use dataset. So what it does is it read the data frame and put it as a flight data frame, and you can convert it as a flight. So you know that within that dataset you have a flight object which has destination country, origin country, and count. So if you are using this, what you do is you are creating object inside your collection. Basically a set of, you're creating set of flight objects, collection of flight objects. So that's what the data set about. Next, the most important thing is, the most familiar one is SQL API. Now if you are coming from, most of us coming from the database background, so our forte is SQL. We have been using SQL from the very beginning of our career. So what Sparks understand is, what the people who develop Spark understand is, okay, most of the people are familiar with SQL. What if we can support SQL API where people can write SQL queries on top of our big data? So they use Hive metadata store for the maintain table. So behind the scene, Spark uses Hive, and you can write Hive queries, basically again ANSI SQL 2003 standard SQL queries on top of your big data, which is a game-changing feature as far as I'm concerned, because you can write SQL queries on top of large volume of data, and large volume of data which may be maintained in the files, not in a relational database. Okay, let's compare these three APIs. You have SQL, DataFrames, and Datasets. Now if you are concerning about the compilations, syntax, and SQL, syntax errors happen in runtime, as well as the analysis errors happen in runtime. But if you go for the data frame, syntax errors happen in compile time and analysis errors happen in runtime. Now the dataset, syntax errors you can identify in the compile time, which means that when you write the code, as well as the analysis errors again in the compile time. So as I said, dataset is used when you want to impose type safety on your data. Now transformation and action. Now if you consider, now in the ETL, extracts, transformation and load. So we extract the data, then we transform the data. So transformation plays a major role when it comes to ETL operations. The transformation means instruction to modify the data frame. When it comes to Spark or the Databricks, when you perform a transformation, as I said, is an immutable collection. It will not modify the existing data frame. Rather, it will create a new data frame. And there's something called lazy evaluations when it comes to Apache Spark. Lazy evaluations mean that, let's say you say that, okay, I want to modify this data frame, which means that I want to join two data frames. I want to do filtrations, I want to do aggregations, and I want to save that data into some other data frames. Just because you instruct Spark to do so, it will not do as it is. What it does is, it will read whatever the transformation you ask it to do, and it will build a logical plan. And once only you perform an action on top of your data frame, it will evaluate, it will execute that logical plan. Now, what is an action? Actions mean that when you have a data frame, when you do the transformation, and if you want to view the output, if you want to write that output to some location, that is something called action. Let me give an example to understand this transformation, less evaluation, and action again. Right. Let's go to this slide. Using an example, I can explain what is transformation and action. Now, I have a file called 2015 Flight Data Summary CSV. Right. So what I do is, I read that data and using Python, and I read and assign it as a flight data 2015. This is a data frame. So this is a data frame, flight data 2015. Then what I do is, I'm creating a new data frame by group this data frame by destination country name. And once you know from the SQL background, once you perform a group by, you need to perform another aggregation for the other columns. So you will count the other columns, and then you're going to rename the columns with column rename. So you are renaming some count column in the destination total, and then you're going to sort that data set using a descending order to the destination total, and then you're going to filter using just to get top 5 records from the this data frame. So these are the set of transformations. You group, you sum, you rename the column, you sort, and you do the filtration. And then what happens is, you're going to see those output saying that new data frame dot show. Now, lazy evaluations mean that until you perform new data from that show, it will not even read the data from the CS file. It will not perform any of those actions on the data frame. What it does is, until you perform show operations, it will just create a logical plan based on the transformation happens. And once when you perform an action only, it will perform all these operations at once based on the most optimized way. So in that case, Spark is very fast because it will not perform an operations on a large file. Rather, it will see whether it does any transformations, whether it does any filtrations, and based on those transformations, it will find most optimized way to perform this transformation. If you go to the right hand side, as I said, when you read, it will create another data frame, because you cannot modify existing data frame. Data frames are immutable. And when you group by, it will creating another data frame, intermediate data frame. When you sum, it will creating another data frame. If you rename it, it will creating another data frame. And if you sort it, it will create another data frame. If you filter by using limit operation, it will creating another data frame. And once you show it, collect it, it will output into the output window. That is how Spark do the transformation. Each step is creating a new data frame. But remember, neither of those actions happen step by step. It will happen at once, and it will happen only when you perform action on top of a data frame. Right. Which language to choose? As I said, okay, you can use Scala, Python, R, and SQL when you're using Azure Databricks. The next question is, okay, which is better? It's an obvious question. There's no something called better when it comes to using languages. It's based on your preferences and available libraries. Now, if you're doing the data engineering, most of the people use Scala. There's a reason for that one. First is, Scala is native language of Spark. which means that Spark is written using Scala language. It's faster compared to other language only when you are doing custom or user-defined functions, which means that when you're using data frame operation, dataset or SQL operations, behind the scene, all of this language converted into RDD operations. So there is no performance differences if you are sticking to standard APIs, data frame, it could be dataset or SQL. But if you are using your own custom functions, then Scala is faster than Python or any other language. But if you see, it's kind of difficult when it comes to learning Scala, maybe to me, compared to Python or SQL. Another thing is less community help compared to other languages, especially for the Python. Python is one of the most used languages. It has a better community and good set of libraries such as Apache Spark. So since they have been using for different purposes and different people, have good community. So they have written good set of libraries. So you can Python in that case. Again, comparably slow in case of large data, but this is also applicable when you are using your own custom functions, not when you are using standard data frame or dataset to SQL APIs. R is used most of the time in the data science, so you have a lot of data science libraries. And one important thing is Databricks supports RStudio, so you can use RStudio to for code using when it comes to Databricks. I think this is the only development tool which supporting Databricks. SQL, obviously, the most familiar scripting language. So it's allow SQL against big data. It's support ANSI SQL 2003 standard. Behind the scene, when it comes to SQL, it's use Hive metadata store to maintain table. Now, if you create tables or database using SQL in Azure Databricks, tools such as Power BI, Tableau can use a JDBC driver to connect to SQL table. Now, if you see, Power BI does support Databricks, but what actually it does is Power BI connect to the Hive tables which are created inside the Databricks, and it can extract the data. But to do that, your cluster must be running whenever you connecting from Power BI to your Azure Databricks. Right. So let's go to my second demo. In my demo, I'm going to cover an ETL operation. What it does is I have invoice files, set of CSV files inside my Azure Data Lake store, and I have a data warehouse in Azure SQL database, and in that I have a people's dimension table. And what I'm going to do is I'm going to read data from Azure Data Lake store, which has my transaction file, and I'm going to join it with the people's dimension, and I'm going to load a table called fact invoice, which has invoice information for the people's for the individual sales person. So let me show my data warehouse table first. So I have my people dimension, which has all the customer, the salespersons, and I have a table called fact invoice, which does not have any record as now, right? So what I'm going to do is I'm going to fill my table and my transaction files are, so my columns are, I'm going to find for each year, for each month, how many dry items and how many total number of invoices done by each salesperson. But when it's come to my data, I have CSV file, set of CSV files in my Azure Data Lake store, right? I have each file for each year. If I open individual file, let's say this one, 2013 sales. Let me open it for you. It will show, it basically a comma separated file. As you can see, you have invoice ID, customer, bill to customer, all those information is basically not a formatted one, but it has invoice information for each customer, each sales officer, but it does not have a salesperson's name, rather it has salesperson's ID. My salesperson's name is in my dimensional table in my data warehouse. So what I'm going to do is I'm going to combine. So let's quickly go to the Azure Databricks. So I have already created a demo. So this is my notebook. So how do I creating a notebook? I'll show how to create a notebook in that case. So this is my workspace, and right click here, you can creating a new notebook. So when you're creating a new notebook, you can say that what's the language you are using and what's the cluster you are going to use. So I'm going to say demo, and I'm going to use Python because Python is my preferred language when it comes to Databricks, and I can select the what's the cluster I'm going to run. So if you can remember, I have already created a cluster called Data Engineering. It's up and running. So I'm going to use that cluster for my Databricks. So I created my notebooks. This is where I'm going to write my code to extract the data and join the data and transform the data and save it the data. I'm going to copy and paste each code because I can't write each and code one by one. Let's go to my already written codes in here. So I have demo pre-built here. So first one is I'm going to read each and individual CSV file and assign it to a data from. So syntax is spark.read, what's the format, and whether your first column, first row is whether it has the header, and what's your delimiter. So my one is not, I forgot, it's not as comma separated, it's a tab delimiter. So I see that my delimiter is tab, and I have to say that where is my file is. So I forgot to mention that you can mount your data lake store into Azure Databricks. So it will act as a internal data file store. So what I have done is I have mount my data lake store into Databricks. So let's copy this code and we'll execute in my newly created notebook. Right. So let's run it. How do I run it? You can either use run all. You have something called run here. If I can run it, you can run the cell. Once I executed it, right, let's see what's the output. So Spark job is running. Okay. So started the job. Job is finished. So it will give you a set of information about what kind of information, so that okay, PySpark SQL DataFrame is created and its name is invoice 2013, and these are the information available inside my data frame, right? And you can go to what kind of operations happens, or directed SLS group operations happens inside. You can go to the details about these operations inside. I'm not going to cover these things because it's beyond the scope of this today's demo, but you can do some researches and you can identify if you see any bottlenecks. You can use this information to identify where the bottleneck is, what happens when I execute each and individual task, right? So that feature is given by the Azure Databricks. Now I only read one file, but I have 3 more files, so I'm going to copy that code to read all the other 3 files, and I'm going to put it. I'm going to create a new cell. You can press Ctrl Alt N, or you can say, if you are in existing file, you can say that add a new cell below, right? Add the new cell above or add a new cell below. So, or you can use shortcut Ctrl Alt N. So I'm going to paste this code. What it again does is it create data frames from these 3 different CSV files. So let's execute this one. Control and Alt and Control and Enter. If you press Control and Enter, or you can go and hit that execute the cell. So what it does is again it create 3 more data frames which has invoice information. Right. So let's see how many jobs. 2 jobs, and 2014 3 jobs. Individual is a individual task is a individual data from creation is a 1 job, and it will give us a 3 more data frames. Right. Okay. The next thing is I'm going to do is I'm going to see some information inside these data frames. So what can I do is okay, before that Now I have 4 different data frames. I want to create one data frame which has all those information. So I'm going to add a new cell, and I can say that I want something called total invoices, which basically does is it's union all 4 data frames. Invoice 13, union all invoice 14, and again union all invoice 15, union all invoice 16. Which happens is all 4 data frames are union and created the one data frame. Let's execute this cell. Now if you can see that these are instantly running. The reason is even though you say that union these data frames, it will not do it at that time. Basically, it will only create the execution plan, but execution does not happen at that time. Then when does all this code get executed? That happens when you perform an action. Let's say that I want to count all the invoices. Total invoices.count. Right? Now if you perform these operations, that's when all the above mentioned steps, all these unions and all the data reads, everything happens at that time, because count is an action, and that is where all the operations happens. Now if you see, now this is where all the 4 files are read, unions, everything's happen at that very moment. Not before, not when you run these union operations, or not when you write these data frame read operations. These are just used to create a what do you call execution plan. Actual executions happen when you perform an action. As you can see, 4 files are read, union and count, and all the things happen at that very moment. Okay. Now quickly let's go to the other things. I can display the total invoices in here if I want to. Let's create a new cell and execute this one. It will show all the invoices. Right? Remember, now you can see that it takes some time. The reason is, again, it will perform all those operations again, because it will not keep your data frame in the memory. It will perform all the read operation and transformation at that moment when you say that display the total invoices. Since I don't have time, let's quickly read the data from my transaction table. So what I do is I'm going to read my dimensional table, which is there in my Azure SQL DB, and put it as another data frame. So I have read all the invoices from the CSV, and I'm going to read all the dimensional information into another data frame. I'm going to execute this one. So it shows me what are the available files, what are the fields. Next, what I'm going to do is I'm going to join this data frame of invoices as well as the people dimensions. What I do is I'm going to join total invoices with people dimension, and I'm going to creating another data frame called join invoices. Let's execute this one. Now we have joined the tables, invoice data frame as well as the my people's dimension. Then I'm gonna do some aggregation. So what I'm going to do is I'm going to group the invoice join invoice table using year and rename it as the year, invoice date, and get the month of the invoice date, and I'm going to rename it as the month and the full name, and I'm going to get total dried item, sum of the total dried item, and I'm going to rename it as the total dried item, and I'm going to get the count of invoice ID, and I'm going to invoice it as a total invoice count. Then what I do is I'm going to display that aggregated invoice data frame. Let's execute this one, and this will be my output. Remember what I did was I read all the invoice from the files, I get the dimensional data from the database, and I'm going to join these two, and I'm going to create year, month, and for a particular salesperson was the total dried item and was the total outcome. Next thing what I want to do is, remember I don't have any records in my invoice table, right? What I'm going to do is I'm going to write that data frame into my table. So this is what it happens. I'm going to add a new cell here, and I'm going to say, okay, aggregate invoice table should be written to my fact invoice table, and my append mode, I'm going to mod this. Either I can override all the tables in my table, all the data in my table, or I can append the data. Okay, let's execute this one, and it will write all the data at that time to my data warehouse. Let's go and see whether it has happened. Let's execute this query again, and you can see that all those data is written to my Azure SQL database. So since I don't have much time, I have 2 more slides, but I'm not going to talk about these things. I will share this slide with you, and please feel free to give your feedback to me. And Jason, since I don't have much time, I can hand over to you right now. And
All right.
please,
So
again, push your feedback to the session.